Good day, guys. It's me, Dr. Iko. I'm from Exclusive Tutorial. And today, we're going to be treating a topic under AEB, cell cycle and cell division. Okay. For those who I believe this should be under AEB 101, then university students, of course, AEB 124. Okay, so today we'll be talking about cell cycle and cell division. First of all, we'll be starting with the cell cycle. We're starting with the cell cycle. Now, the cell cycle involves a series of processes in cell division, or we can also say the cell cycle are like a series of processes in which involves cell growth, in which the cells used to grow. Okay, basically there are two stages. And in these two stages, we're going to be looking at in cell cycle. We're going to be looking at the interphase stage, and the stage of mitosis. Now, no, this mitosis falls under cell division. Now, the interphase stage is divided further into different stages. We have the G1 stage. After the G1 stage, we have the S stage. After the S stage, we have the G2 stage. After the G2 stage, we have the M stage. So we have the G1, the S stage, the G2 stage, and then we have the what? M stage. Now, during the G1 stage, the cell actually prepares itself. It prepares itself, and there's preparation for duplication. So during the G1 stage, the cell is actually preparing for what? For duplication. Now, during the S stage is the actual stage for DNA replication. The cell stage is the actual stage for DNA replication, and we can also say the chromosome replication here too. Chromosome replication. So I said the G1 stage is where there is preparation for what? For replication. The S stage is for what? The DNA replication. Now, the G2 stage, during the G2 stage, a lot of processes take place. Like after the DNA replication and chromosome replication, during the G2 stage, the cell prepares itself for the next stage. Now, the next stage is the M stage. Now, during the M stage, which is what? Mitosis. The M stage is what? Mitosis. Now, this mitosis is further divided into different stages. We have the prophase, we have the metaphase, we have the anaphase, and we have the what? Telophase. So I said that mitosis is divided into the prophase, the metaphase, the anaphase, and the what? Telophase. A very important acronym, or a very popular acronym which you can use to remember these stages, is the PILOMAX. This is a very popular acronym where P stands for prophase, M stands for metaphase, A stands for anaphase, and then T stands for what? Telophase. It's a very popular acronym. Now, these are the basic stages involved in a cell cycle. Now, if you are to represent this, if you want to represent this circularly, you can just, in case you want to remember, you can just create a circle, and divide the circle into segments. We can call this the G1. We can call this the S, We can call this the G2. We can call this the S. We can call this. Then we can call this stage the M stage. While this M stage is divided into the prophase, the metaphase, the anaphase, and the telophase. Now note, from this point to this point is the, you can also call it the interphase. Okay, now let's take a more detailed look at the interphase. Let's take a more detailed look at the interphase. Interphase. Now the interphase is the resting stage of a cell. The interphase is the resting stage of a cell. Now note that the interphase is the longest stage of the full cell cycle. The interphase is the longest stage. Now during metaphase is also the stage with the highest metabolic activity. Which means during the interphase, the cell is actually in its highest form. It has the highest metabolic activity. Now during the interphase, the cell gathers energy. It stockpiles energy, it keeps energy. Now this energy is used for the production of new cell organelles. The energy is used for the production of new cell organelles like the mitochondria, the endoplasmic reticulum, the Golgi complex. This is the function of the energy that the interphase stockpiles during that process. Now note, the interphase is not part of mitosis. The interphase is not part of mitosis. It's a separate stage from mitosis. Some people actually believe that interphase was once part of mitosis. It's not a part of mitosis. It's a separate stage of mitosis. So far we have looked at the cell cycle. We look at where it involves a series of processes for cell division. Then we look at some processes. We said it can either be the interphase or it can be divided into the interphase or mitosis, where we looked at the stages of the interphase at G1, S, G2, and M stage. Then we look at some stages in mitosis. Some stages in mitosis where we said it has the prophase, the metaphase, the anaphase, and the telophase stage, where I gave a cyclic representation here that you can easily use to remember what we are talking about. Mitosis, just in case. Now I said the interphase is the resting state of a cell and it has the highest metabolic activity. Okay, now we're going to be looking at mitosis in view. Now we're going to be looking at mitosis in view in a more detailed way. We're going to be looking at mitosis. Now during mitosis, there is the division of the parent cell into two daughter cells. During mitosis, there's division of the parent cell into two daughter cells. Now note, during mitosis, the number of chromosome in the parent cell is equals to the number of chromosome in each daughter cell. The number of chromosome in the parent cell is equals to the number of chromosome in each daughter cell. Now mitosis, like I earlier said, involves different processes, which is the prophase, the metaphase, the prophase, the metaphase, the anaphase, and the telophase. Now we're going to be looking at each of the following one after the other. Okay. The prophase. Now, during the prophase stage of a cell, if you note the following characteristic, what happens during the prophase stage? Now, the chromatin threads. Okay, normally before cell division, the chromosomes are in form of chromatin threads, and they are usually not visible to the normal eye, even under light microscope. Now, the chromatin threads condenses. The chromatin thread condenses and coils. Hence, they become thicker. So the chromatin thread condenses and coils. Then there is spindle fiber formation. There is formation of spindle fiber. Formation of spindle fibers. Then formation of spindle fibers. Then you should also know that the nuclear membrane dissolves. Basically, the nucleus basically dissolves into the cytoplasm. Then at the end of prophase, the following organelles will be absent. At the end of prophase, the mitochondria, the endoplasmic reticulum, the Golgi complex, would be absent. Now, at prophase stage 2, the chromatin thread condenses and coils into thicker chromosomes. And the other thing you should know that these chromosomes, they pair up and they become joined together at their centromere. They pair and are joined at their centromere. So basically, these are the stages. These are what happens during the prophase stage of mitosis. Then the next stage is the metaphase stage. We'll be talking about the metaphase stage. Now, during the metaphase stage, what basically happens at the metaphase stage is that the chromosomes just align at the center on the spindle fiber. They align at the center. Now, let's say we have something like a cell like this. Let's say we have the centrioles here. Let's say we have our continuous spindle fibers. Now, continuous spindle fibers, our spindle fibers are just run across. And let's say we have a chromosomal spindle fiber. Now, the chromosomal spindle fibers are fibers that are attached to the chromosomes. That are called the chromosomal spindle fibers. Okay. Okay. Now you can see that in the metaphysics stage, the chromosome they are aligned at the midpoints. The midpoints, they are aligned at the midpoints on the spindle fibers. That is basically what occurs at the metaphysics stage. At the metaphysics stage of the cell. Now note that during the prophase stage, the cell actually became more spheroid. That is during the prophase stage. During the prophase stage. During the prophase stage. During the prophase stage. These are additional properties you also like to take. The cell becomes more spheroid, meaning it takes a more spherical form. It is more viscous and non-refractory. It becomes non-refractory. So these are basically other properties of the prophase stage. Now the cell actually became more spheroid during the prophase stage. Now let's take a look at the anaphase. Let's take a look at the anaphase. In the anaphase stage. During the anaphase stage. During the anaphase stage, the chromosomes are actually pulled towards the poles of the cell by the spindle fibers. They start getting pulled to the pole of the cells by the spindle fiber. That's what I'm trying to represent here with a two-dimensional diagram. They start getting pulled to the opposite poles of the cell through the spindle fiber. They start getting dragged to the opposite poles of the cell by the spindle fibers. So that's what happens during the anaphase stage. Now, during the telophase, now the chromosomes have basically already reached the pole of the cells as during anaphase, and by now they already have the same number of chromosomes as that of the parent cell. Now remember that there was replication. The chromosome was replicated during the S stage of mitosis. Now from this replication, they were paired during prophase. Now since they were paired during prophase, they are aligned at the middle during metaphase, and they were put to the poles of the cell during anaphase. Now during telophase, they have probably reached the middle of the cells. So during telophase, the cells actually start dividing, or we also call this cytokinesis. Starts dividing, so that now we can now have two cells. Now after the process of cytokinesis, the spindle fibers disappear. Spindle fiber disappears. Spindle fiber disappears. Now once the spindle fiber disappears, the organelles that were once dissolved, they come back. That is, we start seeing the nuclear envelope, nuclear membrane reappears, and then we actually see the chromosomes, they actually uncoil unquare and unquare, and they once they occur, remember we said during prophase the chromosome condense, they decondense, then decondense back into chromatin threads. They condense back into what? Chromatin threads. Now note, after the telophase stage, the cell immediately enters the interphase stage back. So we can see that it's a cycle. It's a cycle from the prophase to the metaphase to the anaphase, then the telophase, then back to the interphase stage, the G1S, G2, and the G1S, and then the G2 stage. Now another thing you should also note is that the prophase is the longest stage of mitosis. The prophase is the longest stage of mitosis. Now, what are the importance of mitosis? Mitosis is very important for growth of cells, because especially non-reproductive cells. Now, mitosis takes place only in non-reproductive cells because each cell has the same number of chromosomes. So for during replication and growth, mitosis plays a very huge role because of equal division of the cells. The mitosis. Okay. Now let's do a quick review of what we've done up to now. Now we started with cell cycle, then we dropped down the stages of the cell cycle. Then from there, I gave a diagrammatic illustration of the cell cycle, which you can use to remember the cell cycle. Then we went to the interphase stage. The interphase stage, we said, is the resting stage of the cell. It's the stage that has the highest metabolic activity. Then we also went further to talk about the stages of mitosis as to the prophase, metaphase, anaphase, and the telophase. Then we talked about an importance which is very useful. I said mitosis is very useful in terms of growth. So basically that's all for cell cycle and mitosis. In our next class we'll be talking about meiosis in full, or also under cell division. Thank you.